It was an intimate gathering here at the American Meteorological Society headquarters, 45 Beacon Street, Boston, Massachusetts. We heard from Bill Reed, director of the National Hurricane Center, and Lou Uccellini, president-elect of the American Meteorological Society, also director of the National Center for Environmental Prediction, the snowstorm guy. Mark Rosenthal, local meteorologist, with Charlie Orloff on the right, director of Blue Hill Observatory, who organized the event. There's Bill Missinger, along with Bill Reed. And we were listening to discussions regarding the advances in science. Hello, Weir Lundstedt, head of Wintertime Instability Index. We began the evening with a discussion on that Washington, D.C. Snowmageddon.
There were locations in Maryland, Pennsylvania, Virginia, West Virginia recorded more than 30 inches from the first one. Washington, D.C.'s total 17.8 inches was the fourth highest. Washington, D.C. has a crazy way of measuring snow, and everybody complains about, the area right around it has 30 inches, and they have 17.8, so there's definitely an issue there that we'd love to have the Blue Hill folks come down and investigate. Philadelphia and Baltimore clearly had 2+ feet inches of snow, and then the next one you see was 14 to 17, 18 inches. In the local offices, they're going, we better be right. Because if we're not right, we could set our profession back at least 10 years. Because this would be a forecast that they would not forget. Okay. Airlines cancel flights in advance. You all see that? You probably get annoyed by why do they do it. The airline industry has figured out that the worst thing that can happen is have a plane stuck on the runway. But there is one of the great things about this storm, one of the key forecast issues was that northern boundary was a sharp northern boundary in the numerical models. There, while they knew this area is going to get 2 to 3 feet of snow, because normally a storm forms here and it's coming up the coast. So I guarantee you 20 years ago with this kind of a storm, we would have had all kinds of watches and warnings out right up the coast. And it would, okay, slightly different track than what we had. We'll go through again. Yeah. So you see the watches and then the warnings going up. All right. So there were watches and warnings out for this storm. So within that time frame, we had a watch warning out. So people who started complaining about the forecast, we said, hey, wait, time out, time out. Okay. Watch warnings were out. And in fact, I think the lead time on this even exceeded our goals for both of these. So it wasn't like we were, we would say, well, we put a watch warning out, but we put it out the last minute, even compared to our own goals. Converging, it's all staying further out. And this area was now, people were paying attention to it. But New York City, it's going to be light snow, windy, but it's far enough out, okay? Today. Uh-oh. Now you're bouncing back. And here's where the critical decisions have to be made. You've been telling the folks who have to call in people to come in on Christmas night to spin up an operations center on this forecast, when you've just spent the last 2 days showing how it's going further out. Next. Out at this point, okay, 1 day out ahead of time. But the fact is, from a decision support perspective, it's too late. Now, and I'll show you something that's really interesting here. We'll go on to the next slide. Okay, so, in fact, I got this question about, are we better than the European Center or not? European Center has their models. That's this in red. And we have our models, and it's a known fact that the European Center model verifies better than ours on average. Okay? So it's considered the top model in the world, and our forecasters get that model output in advance. That potential was out there, and if people would have listened carefully, this is the same thing with Irene, and I'm sure Bill's going to talk about it. You have that potential out there for the worst case. So what do you plan for the worst, hope for the best kind of thing. Okay? Long polar flow up here, which we did in 2010. You can take a storm track in here, and if they come up the coast, you've got the cold air set in for snow. The main thing about it is these storms behave very, very nicely, as you'll see. Next. So here's the satellite loop for that storm. Notice how coherent it is, goes across. The models, now we flipped from a warm tropical Pacific to a colder Pacific, and what that does is it weakens the subtropical jet, it becomes more variable, the whole pattern is flipped up. So you get this big ridge up over Canada and then a trough down in here. And what this means is that any storm, from a storm perspective, any storm you get developing in here or across the southern U.S. becomes more erratic. It becomes more a function of waves phasing between this flow and this flow here. Harder to predict. The other thing, notice about this, the wet in the Ohio Valley and across, remember where the floods were this year and where the drought is, okay? So we just came out of one of the strongest La Niñas ever, and that drought is one of the strongest signals you get out of it. So let's pick it. It looks pretty solid, and then you say, where did it go? Right? And then it, there it is, okay? Now this is what your models, and then it kind of fools around, and then it blows up on the East Coast, right there. It comes up. And that's what you want us to predict 5 to 7 days in advance. Yeah! So a lot of these storms, it's out there in the ocean, and you're tracking this thing, and people can see it, you know, and they can react to it. You know, look at this, okay? So this phasing and this coming and going, all right, is the uncertainty not only in the system itself, but it complicates your ability to predict it. And we've had examples where when Ron Brown was Secretary of Commerce, and it was 1993, the March storm, and we've been advertising this storm for like 4 days, and then he comes in, you know, because now everybody's getting hyped up about it, making preparations. He comes in and he goes, okay. So this is going to be coming out of our models starting 30 days from, I don't know, what's today? Today's, I've been on the road all weekend. Yeah, so by it's going to be by the end of October. We're going to, October 16th or the 23rd of October, we're actually going to implement this. This is the NAM model, right? This is right, the NAM-B. It'll be the NAM-B. The weather pattern. So the forcing response function is like 2, 3, 4 months.
So is that recent knowledge been brought up as a person to
Janet's having Dr. Uccellini explain La Nina and El Nino to her. What are the odds? As if she doesn't have an expert next to her every night.
Wow. Yeah, but that's not in weather, is it?
Like Sion Avila is from Cuba. He came to this country with a toothbrush and the clothes on his back and worked his way up. Neil Frank gave him a job as a translator for broadcasters early on while he was working on a PhD. He actually got a bachelor's degree at the University of Havana. Pretty rare at random events, and I actually did the calculation of my 40-odd years now of working this stuff. There's been over 1,000 new lines on that. I'm kind of old, man, they happen all the time. But one of the interesting things for up here is if you watch the general trend, and you all know this, they tend to recurve when they're coming north of 25 degrees north. And coming out of there where it's almost solid red, most of them stay at sea. You can see a lot of planet Earth under the lines that come up through here. And so it is kind of like Tim said, it's the rare event that makes all the excitement here. You have enough of them, though, that they're not that rare. You go through the same computer models we use for the winter storms and some of the other techniques we use for it. Most of them were showing an impact up in the Northeast. So I actually got in touch with Bob and Dave and his staff there who do this stuff and said, of these that I've got out there, I had a whole bunch of storms, which ones do you think we ought to be telegraphing to people? These are kind of storms we've had in the past. No two storms are alike, but coming out of the Bahamas, we've had storms in the past that have done this track. And as you can see, the 44 hurricane, how many of you here were around for the 44 hurricane? I didn't think so. But here's the problem. They're rare enough events. To show you the track, it formed right over the islands. We've had a couple of pesky storms that did that. And Louie's talking about this long lead time. Maybe that's true for up here. But think about these folks in the Caribbean or in the Gulf of Mexico. 27 Category 3 or higher storms did their intensification in the Gulf of Mexico that hit landfall as a major storm in the Gulf of Mexico. 2 days, 3 at the most. That's your lead time. All different scales of operations going on. We're responsible for the forecast in the Caribbean. So we're dealing with real-time, right now, dangerous situations in these islands and for what's going to be happening in Puerto Rico. Haiti's a huge concern because now you still have 500,000 people more vulnerable than they already were, and every time they get a big rain event in Haiti, you lose people there. So we're always worried about a storm going close to there, because even though it passes by there like that, on the southern part of the track, the big rain swath behind the storm is coming up out of the south, and the faster you can get it to move away from there, the better off you are. In this case, it moved away reasonably quick. Next slide. So now we're in the Bahamas, and we have a major hurricane. It's Category 3, has a really well-defined eye, really well-defined circulation, really nothing visually in the pattern to indicate that it was not going to stay the same or maybe even get stronger. There's rain that's falling out of these pure tropical rain. Well, we're dealing with radars that start overshooting it in our network. So there's gaps in there where we know we're underestimating the radar rain. And that's why you see, even though you see red there and it's all, some of these other areas, it's not as dark. It may be as much a factor of getting away from the core of the radar as the storms are not really that much weaker. Next slide. That was the end. That was you could tell where Irene went almost by the rainfall track up there. That represents 5 inches or greater in red with the 10 to 15 inch cores in there. One area in the Carolinas of over 20 inches of river base. What? Yeah, that's what I said. 2 beers and an Italian sausage later, and a 4-1 lead, I thought I was in heaven, and then I got to see 37,000 people suffering immeasurably.
Yeah.
I just counted the number of days watching them on TV with my dad, because he bled Red Sox blue and red too. There they go again. You know? That was awesome. That made my whole trip. If you ever get a chance to go there, I highly recommend it. It's actually very safe. They had an article in their paper in a summary of 2010. They had 15 crimes that required